All right, Ozarka here. The next section that we're going to be covering, section 1.2, is going to involve linear inequalities. So the last one was linear equations. This time you're going to see things like greater than, less than symbols, that sort of thing, but within the same context of the linear expressions that we were covering before. The section objectives are listed right here. Write inequalities corresponding to problem situations. So we're going to be doing some of those translation from English to math kind of problems. The second one here, write an interval using inequalities and then graph it. So we're going to be graphing it basically on an x-axis. That's how we're going to be graphing all these inequalities. We're going to solve linear inequalities similar to the last video about linear equations, and then we're going to solve application problems involving linear inequalities. Again, similar to that last section. So as a review, hopefully this isn't the first time you're seeing inequalities. An inequality is an algebraic expression, so it just kind of says right here, involving the less than or equal to, greater than or equal to symbol. So you're going to be seeing that in each of these problems today as we go over inequalities. Using inequalities to describe intervals. Okay, so this is basically more of the language piece in regards to mathematics and the different ways that you can write the same kind of thing. So this first one right here, it says x is greater than k. Well, you can write that in set notation like this, or you can use interval notation. A lot of times you'll see teachers using interval notation the most. Set notation is usually not the norm. And you can kind of just see this for every single kind. So this is less than or equal to, and what that looks like, and then what it looks like for interval notation. We're going to be going over into interval notation in more detail as we go through the problems. I'm not going to really explain it in this section right here, but it'll make more sense in just a second if you're confused on that interval notation. This one, if it's x is less than b and greater than a, you can write it as a compound inequality like that one. Here's interval notation again with the parentheses. This one, x is less than b and greater than or equal to a. Okay, it's similar to the one that was just written, only it's got that equal sign basically right there, and then the interval notation for that. And lastly, x is less than a or x is greater than b. They actually just use the or word when translating that, and then we're going to go over the union symbol with that interval notation. Union is this u notation right there. Okay. The last three examples are called compound inequalities because there's more than just one thing to them. So compound just meaning together. Compound inequalities are associated with and or to explain them. And again, we're going to be doing more example problems, so this will make more sense. But it's basically and is more is both things have to be true, where or is one or the other. Let's see here. We kind of talked about this union symbol as well. There's the opposite, so it says to denote an intersection. It's the union but upside down. We're not really going to worry about that so much in this section, but the union for sure we're going to be going over. All right, and then it says to graph an inequality, we shade the intervals along a number line. We're just going to be doing an x number line, an x-axis number line, and we're going to use parentheses or open dots to exclude endpoints. It'll kind of make more sense as we do that as well. The brackets and closed fill dots will also be used. All right, let's look at some of these examples to kind of make sense of all this notation here. So example number one, it says, write an inequality that represents the following problem situation. And it says the truck weighs less than 2,000 pounds. We're just going to have x be the weight of that truck. And since it's less than 2,000 pounds, you're just going to want to write x, meaning x being the weight of the truck, is less than, so you'd use the less than symbol, and then you would put 2,000 like that. And that's basically the answer. There's not much to it for these. Once we start solving, there's going to be a little bit more steps, but for these, there's just going to be a lot of translation. So, all right, the next one. Write an inequality that represents the following problem solution. The car's fuel efficiency is no less than 40 miles per gallon. So it's no less. That means it does not get any less than that. It could be equal to it, though. So we're going to say x can be greater than or equal to 40 for this one. That's what no less basically means. You can kind of reword that if you want. Just it can't be 39, 38, that sort of thing. So it could be greater than 40. It can't be less than 40. So it could be also equal to 40. So that's why I wrote x is greater than or equal to 40. All right, the next one, it says on a number line, graph the inequality x is greater than or equal to 8. So what we're going to do here is I'm going to just draw a number line. And the number line forever goes to the left and forever goes to the right. So I'm going to put arrowheads on that. And then the only number that we need to really worry about in this one is 8. So I'm just going to draw an 8 on the number line. To the left of the number line is like 7, 6, 5, 4, 3, 2, 1, -1, -2, and so on. To the right of that 8, it's 9, 10, 11, 12, 13, all the way to infinity. We basically need to graph the inequality x is greater than or equal to 8. So to do that, what we're going to do is we have to include the 8. So we're actually just going to color it in on the 8 like that. Now it's greater than 8, so we're actually going to be going to the right. So we're just basically drawing an arrow like this and to the right. So that red dot and arrow to the right is basically representing the graph of that x is greater than or equal to 8. Now sometimes they actually do put this just right on the number line, but sometimes it's hard to see, so I kind of just put it a little bit above it. You can obviously do that as well, unless your teacher says otherwise. But for my classes, that's completely fine to do for the answer, and that's basically all you do for that one. Next one, similar kind of thing. It says on a number line, so I'm going to make the number line really quick. I'm going to put 5 on the number line, like so. Now it's w is less than 5. So I'm going to put, we're not actually including 5, so it's going to be an open circle. If it's less than it, then we're going to go to the left this way, and you end up with something like that. All right, number 5, now it's kind of backwards. It actually gives you the number line, and you have to figure out the algebraic inequality corresponding to that graph that's showed on that number line right there. So first of all, obviously it involves -4, and we're going to use x as well. So we just need to figure out what's the symbol. Is it greater than, less than, greater than or equal to, less than or equal to, that sort of thing. Well, obviously it's going to the left, so it's going to be less than. X has to be less than -4. It's also colored in here. So since it's colored in, it's a closed dot. We're going to put a equal sign there as well, so it's going to be x is less than or equal to -4. All right, number 6, it says on a number line, so I'm going to make another number line really quick again. And this one is going to have 2 numbers on it, -3 and 1. It has to be in numerical order going left to right, otherwise the number line is not going to work. So -3 has to be on the left. And we're going to treat each individual parts of these as their own little problem in a way. So the x is less than or equal to -3. That's going to be colored in because it's less than or equal to. Less than is to the left. So I'm going to draw something like that. The other one, x is greater than 1. So I'm going to circle that. And it's going to go this way. Now, one thing that you'll notice on this is there's no overlap on this, and that is completely okay because it's or. It could either be less than or equal to -3, or it could be greater than 1. So it could be either of those. If it's an and, then there has to be overlap, and if there's overlap, then that's what the answer is. In this case, we don't care about the overlap. For number 6, if we actually did care about the overlap, the answer would be there is no answer because there is no overlap. They literally go in opposite directions and never cross. So we don't have to worry about that, again, for this one because of the or. Okay, the next one, on a number line, graph the compound inequality. Okay, so I'm going to graph the number line here. It goes forever this way and this way. The number to the left is -1. The number to the right is 2. Now, it says that x is, I'm just going to read it going this way. X is greater than or equal to -1. So x is greater than or equal to -1. So it's going to be colored in here, and then it's going to be going, and it's going to be going to the right. That's the first part. That's the first part. The next part is x is less than or equal to 2. It's going to be colored in here, and we're going this way. But now if you notice, they're going in opposite directions, but they both have to be true. So the answer for this one is just where there's overlap. Okay, so what I'm going to do, I'm just going to treat that as like me showing my work, and I'm going to actually have my final answer over here. The final answer would just be where they overlapped, and they overlapped from -1 to 2, and you would want to make it like that. Okay, so this right here, I'll actually highlight it to show that this is the final answer. The other part is not the answer, it's because it has to show that overlap, because they both have to be true. It's not an or where you can just have one or the other. In this case, you have to have both, and it's where the overlap is. Write an algebraic inequality corresponding to the number line below. Okay, so it's definitely going to be an or, because there's no overlap on this. This first part right here, it's going to be x is less than 2, because it's going to the left. This other one's going to be x is greater than or equal to 4. And the last step basically would be to put that or in the middle of them. And that would be it. Now, if we wanted, it doesn't ask for it, but if we wanted, we could actually put this in interval notation. It's probably a good way to actually start explaining what interval notation is all about. For this one, it says x is less than 2. Okay, so that means the smallest that it can get through, and this part right here, the smallest that it can get to is negative infinity, because it can just keep going less than 2 over and over and over again. So the smallest number goes first. Then you put a comma up until the biggest number. Well, the biggest number for this piece is 2. Even though it doesn't actually reach 2, the biggest possible number that's related to it is that 2. Okay, now it never gets to the 2, so you would have to put a parentheses here rather than a bracket. If it was actually a closed dot on that 2, then you would use a bracket, but since it's not, we're going to do a parentheses. Yeah, you always have a parentheses on negative infinity because you can't actually reach it. You don't want to put a bracket on there. Okay, the union is where we're going to take into account that or, so I'm going to put a union there. So for that other piece, the smallest we can go is a 4, and the biggest, because it's infinity, goes to the right forever, is infinity. Parentheses always on the infinity. The 4, though, is going to have a bracket, so that's kind of what we were talking about before. Instead of parentheses, because we're including the 4, I'm actually going to include the bracket on it. But again, that's not what it's asking for on this one. It's only really asking for this part right here. But it's probably a good spot to actually show interval notation. Let's actually do the same thing for number 7. Let's do this one in interval notation. You always start with the smallest number first. So in this case, based on this graph right here, the smallest number would be -1. The biggest number is 2, and we include the ends for both of those, so we would put brackets for that. We'll do more examples involving interval notation in just a second. I just kind of wanted to preview it a little bit with these problems. All right, let's go to problem number 9. All right, so problem number 9 involves solving inequalities. And this is similar to what we were doing before when we were solving linear equations. It's the same kind of thing, except there's one different rule that we kind of have to make sure we're aware of. When solving a linear inequality, whenever you multiply or divide across by a negative number, you must reverse the inequality symbol. So it's kind of highlighted in yellow right there. So anytime we're dividing or multiplying by a negative, you have to flip that symbol. Because essentially when you're multiplying by -1, you're changing the entire direction of the numbers on the number line. Because if you think about it, if you're going to the right and you multiply by -1, negative is to the left. And vice versa, if you multiply a negative by a negative, you're flipping the sign basically, and you're flipping the direction of it, which you're pointing. So you have to flip the inequality symbol is the moral of the story. So number 9, it says find the solution set, and then it says write the solution set in interval notation and graph it on a number line. So we're actually going to solve the inequality and graph it on a number line and do interval notation. So this problem is good because it kind of encompasses everything that we're covering for this section. So first thing we're going to do is divide this up here, the left and the right side of that inequality. And let's start solving this inequality. So first thing we're going to do is subtract 5 on both sides. Okay, I'm going to put a little barrier up there. Okay, now the reason we're doing that is, again, the goal is to get W by itself. So we got rid of that 5. Next is we're going to get rid of that -4. But in the meantime, let's actually just rewrite it here. We got -12 right there. All right, next step is we're going to divide both sides by -4. In order to isolate that W, I'm going to put another line right there. Okay, the -4s are going to cancel because -4 over -4 is 1. And since we divided by a negative, it is important to note that we have to flip the sign every single time whenever we do that. Okay, that ends up being the answer. And just like the last video, if you wanted to, you can actually check this by picking a number that's greater than 3, like maybe 4, plug it into the original inequality and seeing if it's true. I'm not going to waste the time in the video to do that, but again, it's completely up to you if you want to do that. Okay, now it says we need to write this in interval notation. Well, to write this in interval notation, it says W is greater than or equal to 3. That means that 3 would be the smallest you can be. Because after 3, you're only greater than it. You're equal to it or you're greater than it. You can't be less than it. So the smallest number is 3. The biggest number, since we're just going for greater than, is just going to be infinity. You can't actually ever get to infinity, so you put the parentheses on there. You do include the 3 on this, so you have to have a bracket. And this is how you would write that answer in interval notation. Bracket 3, comma, infinity. Now it also says that we have to graph it on a number line. Okay, so what I'm going to do is draw the number line, just like we were doing before. Okay, we're going to put 3 on the number line. It goes forever to the left and forever to the right. Let's see here. It includes 3, so you're going to want to do a closed dot. Now we're going to infinity, so infinity's to the right. And there we go. That's the answer. That's all 3 parts of the answer, actually. So we solved. We found the solution set, we wrote the solution set in interval notation, and graphed it on the number line. Now the solution set can be any of those. So I also included that inequality part to it, but that's because we're solving it. It makes sense to kind of graph or to answer it that way. But hopefully that makes sense. Let's go on to the next one. Now, since we just did that one, it's probably a good idea to actually try to do this one on your own. So what I would do is pause this video, try to work this problem out on your own, and then when you're done, to check it, just play the rest of the video and kind of just assess yourself as we're going through the problem. So I would pause it here, solve it, and then unpause it, and you'll watch the rest of the video to see if you were right or not. Okay, just like last time, I don't like fractions, so I'm gonna multiply everything by 7 to get rid of it. Remember, multiply by the denominators, it gets rid of the denominators, which means you don't have any fractions anymore. So now we have negative 28 is greater than negative 4v plus 42. And now from here, let's subtract 42 from both sides so we can isolate that v variable there. This will cancel, and you're gonna be left with negative 4v is greater than. And while I'm at it, I'm actually gonna separate this out so it's a little bit easier to see. Okay, and then negative 28 minus 42 is gonna be negative 70. Okay, from here, I'm gonna divide both sides by negative 4. So again, we're dividing by a negative, so we're gonna have to flip that sign there. So now it's gonna be v, the greater than symbol is gonna be flipped to a less than symbol. And then we have the 70 over 4. Well, 70 over 4 can simplify to 35 over 2. That's basically the answer written as an inequality. But it also wants an interval notation and graphed on a number line. So the interval notation, it says it's greater than 35 over 2. So that means 35 over 2 is the smallest that we'll ever get, but it can get greater than it, so it can go to infinity as well. Okay, we do not include the 35 over 2, so you're going to have to put a parentheses instead of a bracket by that 35 over 2, and you end up with an answer like that. Okay, on the number line, we're going to put 35 over 2 on that. We're going forever to the left, forever to the right on the number line each time, so make sure you include those arrows. And the smallest that we're going to get is 35 over 2, and we're not including it, so it's going to be an open circle, and then it goes forever to the right, and you get the answer graphed. So you have the inequality, the interval notation, as well as the graphing for that answer. Number 11, find the solution set. Write the solution set in interval notation and graph it on the number line. So more of the same kind of problems here. I'm actually going to, again, separate this out, but this one's a little different because there's multiple distributive properties that we have to do on this. So let's start simplifying that first. So negative 24 plus 7 times 3 is 21. 7 times negative x there is negative 7x is less than or equal to negative 3x minus 27. Okay, so we got x's on either side of the equation. I'm actually going to move them all to the right because, I don't know, I just always do that biggest negative one there, which is the 7x. So I'm going to add 7x to both sides. That's going to cancel out these two right here. And then I'm going to get rid of the constant on the right. So I'm going to get rid of this 27. Add it to both sides. Again, notice the colors. You will notice that what I did to one side, I equally did to the other. You have to make sure you do that when solving these equations. Don't just do something to one side and forget about doing it to the other. This is going to cancel here, and you're going to be left with 4x is greater than or equal to, okay, negative 24 plus that 27 there, that's going to be 3. And then you're adding the 21 to it right there, so then you get 24. Okay, from here, we're going to divide both sides by 4. 4s are going to cancel. 24 over 4 is obviously going to be 6. So the final answer, written as an inequality, is x is greater than or equal to 6. But it says write the solution set in interval notation. So again, with interval notation, you always start with the smallest possible value. If x is greater than or equal to 6, the smallest you can get is 6. You're including it, so it's going to be a bracket. And then you can go greater than it, so we're going to infinity. So it's going to be bracket 6 comma infinity for the answer in interval notation. And then to do that on a number line, to express this exact same value, we're going to put 6 on the number line like that, forever to the right, forever to the left. We're including the 6, and then we're going to the right. So that's the answer as a graph. All right, this next one, find the solution set, and we're writing the solution set in interval notation as well as graphing it. So similar to the other problems. Again, we have 2 things to distribute on this, so let's do that really quick. All right, so the next thing is, you'll notice there's negative 4x on one side and negative 4x on the other. So if we add 4x to both sides, what's going to happen is this is going to cancel and this is going to cancel, and then you're going to be left with negative 12 plus 33, so that's going to be 21, is greater than or equal to 24. Now the problem with this is 21 is not greater than or equal to 24. So the answer for this, similar to what we did before with the equations, if what you end up with after the variables cancel not being true, for example, 21 is not greater than or equal to 24, the answer would be no solution. So again, if you haven't seen that last video on solving linear equations, you would see that there is no solution on this if that final part is not true. There's no value that we can put in there that makes it true. It would be no solution. All right, so for the next one, it says find the solution sets, write the solution set in interval notation and graph it on a number line. So same kind of thing. I'm going to distribute this out really quick. So the 4 times 7 is going to be 28 minus 4w plus 4w is greater than or equal to 25. From here, these are going to cancel, and you're going to be left with 28 is greater than or equal to 25. Now that is actually true. Okay, 28 is greater than or equal to 25. In fact, it's just actually greater than it. So that means that there's infinitely many solutions. Okay, so all numbers would work for this. And how do you draw all numbers with interval notation? You would say from negative infinity all the way to positive infinity. So that would basically include every single possible number because you're going forever to the left and forever to the right. Any of those numbers would work. Then it says graph it on a number line. It's not really exciting to graph this on a number line because you just have an arrow going to the left and to the right, basically. So there's no actual numbers that we need to worry about on this one. So you can just actually just draw a number line going left and right. Okay, not very exciting, but that's the answer for it. 14, it says find the solution set for the compound inequality, write the solution set in interval notation, and graph it on the number line. Okay, so now we have an OR that we're going to try to solve for, and then we have to use a union because it's an OR for this when we write it in interval notation, and then we're also going to graph it on the number line. Okay, first thing we're going to do for the problem on the left is I'm going to divide everything by 4. If you notice, every term has a 4 in it. So I'm going to divide everything by 4. Makes it a little bit easy to work with. Subtract 1 on both sides. And you're going to have x is less than or equal to 0. Okay, so that's part of it. Or whatever the answer is over here, we're basically going to combine it with this. So first thing I'm going to do on the right part of this is add 3 to both sides. All right, once I do that, you're going to have 2x is greater than 8. Divide both sides by 2. So divide by 2, divide by 2. Cancel, cancel. X is greater than 4. So now we have the answer being x is less than or equal to 0, or x is greater than 4. Okay, so that's the answer written, in inequality format. But how does this look in interval notation? So we're going to start with the smallest number first. It says x is less than or equal to 0. Well, less than 0, well, that's just negative infinity. That's the smallest number that you're going to have on this. And it goes up to 0 and it stops. It actually includes the 0, cannot include negative infinity. So make sure you have the bracket and the parentheses like I just have right there. The next part of it, it's going to be 4, but it's x is greater than 4. So 4 is the smallest, but it goes to infinity. But it goes to infinity. And we can't include infinity. We can't include the 4 either. And then we're going to need a union on this because it's the OR. So don't forget to put that union in there. And then that's the answer for the interval notation. Now how you would graph this on a number line would be the following. I'm going to put both numbers on the number line. So we have the 0 and we have the 4. Forever to the right, forever to the left. The 0, it's going negative infinity to 0. So it's going to be 0 and then pointing to the left. The 4, it's greater than 4, but it's not including the 4. So we have the open circle and it goes forever to the right. And that's basically the answer graphed out for this one. And last but not least, we have number 15. Again, find the solution set, write the solution set in interval notation, and graph it on the number line. This one has an and on there, so hopefully there's an overlap here so we can kind of figure out what the answer is for this. So first thing I'm going to do here, divide these up. Same with over here. I'm going to divide everything by 4 again. So this is going to be u minus 1 is less than 0. I'm going to add 1 to both sides. So then you have u is less than 1. And, so now we have to figure out the second part. And whatever we get for that other part here. So we're going to add 1 to both sides first. So plus 1 there. It's going to cancel this out here. And you have 3u is greater than or equal to negative 6. We're going to divide both sides by 3 to cancel out that 3. And you end up with u is greater than or equal to negative 2. So it's u is less than 1 and u is greater than or equal to negative 2. And it has to be the overlap because it's and. It's not one or the other. They both have to be true. So it has to be the overlap. I'm going to go straight to the number line because it kind of shows the overlap a little bit better for this. So on the number line, I'm going to put negative 2 and I'm going to put 1. Again, we're looking for the overlap. So the 1, it's u is less than 1, so it's an open circle pointing to the right. The other part is going to be u is greater than or equal to negative 2, so it's closed circle and it's greater than it going this way. The overlap, as you can see, would be in this middle section right here, so it'd be from here to here, and it would be inclusive right there. Again, it has to be what they overlap. That purple is basically going to be the answer for the graphed out part. We don't actually need the other part anymore. And it's going to be negative 2 going to 1, not including the 1, so parentheses, bracket on the negative 2 because it's including the negative 2, and then we're going to highlight it. That's the answer. So there's the graphed answer and the interval notation answer as well for that. So that's basically linear inequalities, a bunch of example problems. We did some problem situations where it was like modeling the real world and translating from English to math. If you have any questions on anything in this video, let me know.